In this tutorial, we'll be learning how to construct bivariate tables in SPSS. For the examples today, we're going to be using the NES 2000 dataset. And what we're going to do is look at three actually, different hypotheses and how we would construct a bivariate table to test those hypotheses. Our first hypothesis is going to be dealing with a question about religion and how different religions attend religious services. And what we're wondering is whether people of some religions attend religious services more often than another religion. And there are a couple of variables in the NES that will let us test this. There's a religious category variable. It shows you which denomination people are. And then there's a religious attendance variable, which shows how frequently people attend religious services. So let's go ahead and conduct a crosstab or percentage table to take a look at this relationship. To do this, click on Analyze. Go down to Descriptive Statistic. Wait a second, you're saying. Descriptive Statistics? This is not a descriptive statistic. This is a bivariate statistic. How come it's stuck here in the Descriptive Statistics menu? That's an excellent question. It's one of those quirks of SPSS, but that's just where they put it. Go across to the Crosstabs selection and click on that. We'll sort our list by variable name alphabetically. And you'll see that there are two boxes here, rows and columns. And these are where you enter the variables to define what are the columns and what are the rows. And if you remember from the lecture notes, columns cause rows, right? So we enter our independent variable into the column, we enter our dependent variable into the row, and that's the best way to keep it straight. Columns cause rows. So in our example, our independent variable is religious category, so the denomination. So we'll take that and we'll put it here. And our dependent variable is how frequently people attend religious services, and that goes into the row. Okay. Now, if we just run it this way, it will give us the raw numbers in each cell, and that's not very helpful for us. What we need to know are the percentages, and we want those percentages to be available in the table for us to see. To get that, we need to click over here on the Cells button. Now this allows us to define what we want to exist in all of those crosstab cells. It's going to give you the observed count, so the number of cases that fall into each cell, but what we also want are the percentages going down each column. And we do that by checking the column option in the percentages area. Okay. And click Continue. Now we can also, right from this menu, get some of those measures of association that we want to look at with the crosstab. And you get to those by clicking the Statistics box. Now for our variables here, we have really one nominal variable, so religious category, Protestant, Catholic, Jewish, other, that's a nominal variable. Religious attendance is an ordinal variable because it goes from less attendance to more frequent attendance. But when you have at least one nominal variable, you're stuck using the nominal measures. Now, SPSS neatly categorizes these for you into two different areas, nominal and ordinal. But what we want to get for our nominal is our lambda, but we also want to ask for Kramer's V because sometimes lambda doesn't work out very well. So we can ask for both those measures at the same time. Hit Continue, hit OK. So here's our crosstab. Now you can see you read these across. So these are column percentages. You can see that this plus this plus this plus this plus this sums up to 100%. Now if you've done this wrong, the 100% are going to be along here. So that's one thing to look for after you produce a crosstab. Do you have 100% across the bottom? And if you don't, you've done it incorrectly. Now when you're interpreting a crosstab, you read, even though there's some percentage down, you read across. So what you're interested to know is whether the percentages across each row vary. If they're the same across the rows, then there's no relationship. In this case, we do see a pretty significant difference. About 41% of Protestants attend religious services every week. Fewer Catholics do, 36%. Even fewer Jews attend religious services every week, 18.5%. And people of other denominations are somewhere in the middle. Similarly, if we go down and look at those who attend only a few times a year, we see that Protestants are only about 21% in that category, or I should say only about 21% of Protestants fall in that category. Roughly the same for Catholics, but among Jewish respondents, over half said they attend services only a few times a year. So it does seem like there's a relationship that some denominations, Protestant, attend more frequently. Other denominations, like Catholic, attend a little less frequently, and Jewish people of the Jewish faith attend even less frequently. Now we can use our measures of association to get a handle on how strong this relationship is. We can go first and look at lambda. Now, the way that SPSS works is it gives you a whole bunch of statistics here. So which ones are you looking at? Well, first of all, Goodman and Kruskal's tau we can just ignore because we're really interested in lambda. Lambda provides three different measures. There's what's called a symmetric measure. There's one using one of the variables as dependent, and then there's a measure using one of the other dependent variables as, or one of the other variables as dependent. What we need to do is figure out which is the right one for us, and it's going to be the one that has the dependent variable that we're using as the dependent variable. In this case, how often people attend religious services. It's this second row. Okay, and the value for that is 0.017. So it looks pretty weak according to this measure of lambda. Now, one of the things you'll note is that if you construct your crosstab correctly, where you put the independent variable here in the columns and your dependent variable down in the rows, that when you go to use the lambda table, the second entry is always the proper one to use, because the way SPSS does this is it always puts the variable that is forming the rows as the second one here dependent. So if you do this correctly, you can always know that you're supposed to look at the second value here in the table. Now that looks like to be a pretty weak variable, but it's non-zero, so there is some, lambda is working to provide a measure of the proportional reduction in there, but it's a very small PRE. We can also rely to some extent on Kramer's V. Now, as you'll see here, just like this box produces phi, which we're not going to use. We're going to focus here on Kramer's V, so just ignore phi. And you can see that the value here is 0.151, which is a good bit larger than lambda, and that's often the case. Remember that lambda is a PRE measure, and Kramer's V is not a PRE measure. It's calculated differently. So you'll often get slightly different values, sometimes substantially different values. Which do you use? That's a good question. I think generally speaking what you want to do is sort of triangulate. This is going to tell you it's a pretty weak relationship. This is going to tell you it's moderate, so perhaps you're best off calling it a weak to moderate relationship. Let's try a different example now. Here's the question we're going to consider. Does gender influence party identification? And specifically, are women more likely to be Democrats than men? You can go up again to choose our crosstabs. All right. Let's get rid of that variable and get rid of that variable. And we're going to put into our dependent variable box party ID. Okay. And that goes into the rows. And our independent variable, which is going to be gender, here's the variable sex that goes into the columns. Okay. We have our cells correct. We have our column percentages selected. And in our statistics, we still have these nominal things checked. And is that what we want? Well, let's think about that. Is sex a nominal variable? Yes, it is. Party identification, well, it's probably safely considered a nominal variable. So we're going to be having to use these two choices for our measures of association. So click Continue, click OK, and here's our output. So you can see here's the gender categories, and here's the party ID summary. And if we look at this, we can see that among strong Democrats, there is a little bit of a tendency for women to be more Democratic than men. In the weak Democratic category, there are more women than men. A little bit the opposite here at Independent Democrat. They're slightly more independent. And then as we move into the Republican, we see that men are more likely to be Republican than women for both Independent Republican and weak Republican and strong Republican. So it does seem to support our hypothesis. Now we can also look at our measures of association. Let's look first at lambda. Remember, we go down to the second row, and here we have 0, 0, 0. This is one of those things that happens with lambda. And the reason is that the mode for both of these is the same, strong Democrat, right? That is to say, most females fall into the strong Democratic category, and most of the males, or the largest proportion, the modal category for males, is strong Democrat. And when you have that, and they're both the mode, even these differences that we see turn out to be 0 with lambda, just because of the way it's calculated. So in these cases, you can ignore lambda and instead go and take a look at Kramer's V, which has a value of 0.118, which is a pretty moderate relationship. So in this case, we would say lambda doesn't really work, so this relationship is moderate. Let's do one final example. Are more educated people more opposed to the death penalty? Well, we can again use the NES data to examine this question. We'll go back to our crosstabs box, get rid of that variable, get rid of that variable, and we're going to go up and use a measure of education called EdSum. That is our independent variable, and we want to know their opinion on the death penalty. Oops, going the wrong way. There it is. Okay, and that goes into the row. So remember, columns cause rows. You can always, before you press OK down here, go make sure that makes sense. Columns cause rows. Education causes death penalty opinions. Okay. So again, we want to check our cells, make sure our column percentages are chosen. We want to go and check out our statistics. Now we need to figure out whether we have ordinal or nominal variables here. Well, our EdSum variable, if you right-click on that, you can pull up the value labels. This goes from less education to more education, so this is coded as an ordinal level variable. What about the death penalty opinion? Let's take a look at that. This is from favor strongly down to oppose strongly. So this is ordered too, right? Because this is most opposed, a little less opposed, a little even less opposed, and those in favor. So it really creates an ordered list here. So what we're dealing with are two ordinal variables. So now we need to change the statistics we asked for. We don't want Kramer's V, we don't want lambda, instead we want gamma. Hit OK, hit OK, and here's our output. Now as we look across our rows, we can see some differences. Over here in the favor strongly column, about 50%, 60% of those towards the bottom end of this education list are going to favor strongly the death penalty. And it peaks out here around 59% around in this area. But then as we get to the more advanced education levels, support for the death penalty seems to drop off, right? Only 48% of those with a bachelor's degree favor strongly the death penalty, and only 40% of those with an advanced degree. So it's not a monotonic decline across education levels, but there is certainly a difference between those who have only a high school or community college degree and those who have a college or advanced degree. So it does seem like the relationship holds. We can also use our measure of association to help us figure that out. We can come down here and look at gamma, which takes on the value of 0.091, which indicates a weak relationship, but one that's there, and also that one that's positive. So what we can see is that as we go larger on this variable, as we go to higher levels of education, we go down this. We go higher on this list as well, right? So higher values of this variable are associated with higher values of this variable. So those with advanced degrees are more likely to oppose the death penalty, and those with lower levels of education are more likely to favor the death penalty. That makes sense for our hypothesis. So sometimes when the numbers here are a little confusing, and this kind of goes up, and then it goes down, and then it goes up again, and then in this category, well, they seem to be a little higher here than these people do for favor not strongly. Sometimes in that situation, it's useful to come down and take a look at gamma to figure out the pattern of the relationship. Is it really fair to say that increasing education means more likely to oppose? And gamma does tell us that there is a relationship here, and it's a positive one.